Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we proceed with another lecture of statics and dynamics, that is relative motion analysis, or the short form is RMA. And today motivational quote is never give up on what you really want to do. The person with big dreams is more powerful than the one with all the facts. And outline of today's lecture is introduction to RMA, one-dimensional RMA, two-dimensional RMA, relative velocity and relative acceleration. Okay, as an introduction, previously we have described particle motion using coordinate referred to fixed reference axis. So previously we have learned about rectilinear motion and curvilinear motion, and both of these have fixed reference axis O, either in linear or in curvilinear, and the displacement, velocity and acceleration so determines a term absolute. So for based on this we have displacement, velocity and A that is absolute from this O. However, it is not always possible or convenient to use as fixed set of axes to describe or to measure motion. Okay, because not all real situations have a fixed set of axes. There are many engineering measurements made with respect to moving reference system. So the real situation, many of it made respect to moving reference system. This measurement, when combined with the absolute motion of the moving coordinate system, enable us to determine the absolute motion in question. This approach is called relative motion analysis. So this one, there are no fixed axis, but it is referred is referred to moving reference system. Okay, so relative motion analysis is one method used to analyze bodies undergoing general planar motion. So to analyze the motion in general planar motion, and general planar motion is motion where bodies can both translate and rotate at the same time. Okay, for the one-dimensional RMA, for example, we have linear motion like this. So we have A and we have B particle. So the displacement of particle at an instant is SA. So this is the displacement of particle A. And then SB is displacement of particle B at the same instant. Okay, this is SB. SA and SB. And displacement of A respect to B is as this SA dot slash B. So that means A relative to B. So the displacement of A relative to B is from B to A. Okay, and displacement of B relative to A. So from, let's mean relative to means from. It's same as from point, from that point. So this one is displacement B from A relative to A. So from here to here. So how to okay, therefore the SA, the vector for displacement A can be write as SB plus SAB. Okay, SB here and SA slash B. A slash B is in the opposite direction. That's why SA equal SB plus SAB because it's same as negative. So SB equal SA plus SBA. So this is different. This is AB and BA. So SA plus SBA. So can the displacement of A relative to B is SA minus SB, and displacement of B relative to A is SB minus SA. And for the relative motion analysis in 2D, so okay, previously this is 1D because this is linear motion, and for curvilinear is 2D. 2D, so we have particle in curvilinear motion in different position. So for example, we have the displacement of particle A at instant is RA because this the reference is O, reference point. And RB is the displacement of particle B at the same instant. And the displacement of A relative to B, okay, A relative to B, that means toward A from B, toward the toward A from B, so here, and RBA is toward B from A, toward B from A here. So RA equal RB plus RAB. Okay, RA is like this and RB is like this. RAB is like this. Okay, this is the formula or the theory that we apply at the first static lecture. That means if we want to get this is the resultant. For example, when we add RB plus here RAB, we will get the here this means from tail to head. So combine the tail to head is the resultant forces. There is for forces, but this is same because this is formula for vector. So RA equal RB plus RAB, and RB here equal RA plus RBA because RBA is in the opposite direction. Okay, so you will get this. Just replace the equation, and for the this one is for displacement, but when it is derived, so we will get differentiation of B, we will get velocity B. So differentiation of A, we will get velocity A. So it's equal. So from equation, okay, from equation R, we will get the equation V, velocity. And okay, this one, okay, this one is same as previous. There is the velocity B equal velocity A plus velocity B relative to A. So you will get this, okay, same as previous. And also, okay, the main equation is RB equal RA plus RBA. So when double time differentiate with respect to time against, that means to time, we will get A. AB equal AA plus ABA. And okay, you will get A, acceleration of B relative to A is AB minus AA. Okay, so for the relative velocity, okay, from previously, we have this equation, okay, because this one is B and this one is A and BA is this, okay. So we use that equation, so for BA, and then okay, this one is okay, the main equation, and then in this situation there are combination of rectilinear and curvilinear, and for rectilinear the velocity of particle is in direction of the motion. So if the, okay, for example, if a particle move like this, for example, and the V, okay, for example here, and the V is in this, okay, in the direction of motion, so we put there. And curvilinear motion, velocity of particle is tangent to the curve and in the direction of motion. So here we have center origin here, and the tangent is like this. So V like this. That means toward toward up, because it's follow the direction of motion. And there are two methods that you can solve the question of relative motion for the relative velocity. That is, the first method is to use trigonometry method, and second use rectangular method. I will explain the two method of analysis later in the example. And for relative velocity, there are 6 quantities involved. That is the, okay, we have VA, VB, and VB relative to A. So for all these parameter, we have magnitude and direction. So 2 times 3, so there are 6 quantities that we need to know to solve the relative velocity, and check that they must be two unknown in to analysis. Okay, this is uh, the characteristic of relative velocity. And for relative acceleration, the equation is AB equal AA plus ABA. So the acceleration of B relative to A is equal to acceleration of A minus acceleration of B minus acceleration of A. Okay, and it can be divided into rectilinear motion and curvilinear motion. And for rectilinear motion, if the particle accelerating, the acceleration is in the direction of the velocity. And if the particle decelerating, the acceleration is opposite of the direction of velocity. Okay, for this one is rectilinear motion. For example, you have this is O, A, B. So for example, you have acceleration of A, acceleration of particle A toward right. It is in the okay, for example, A positive. A positive is toward right, but negative A is toward left. Okay, that is based on the direction of velocity. Next, you need to know where is the direction of velocity. And for curvilinear motion, velocity of particle is tangent to the curve and in the direction of the motion, and acceleration is resolved into two components, normal component and tangent component. Okay, for example, you have curvilinear like this. So, and this is the AN and this is AT. Okay. For the AN, for the normal component, the magnitude is V squared over rho, where V is the velocity and rho is the radius of the curvilinear. And the direction is toward the center of rotation in the positive axis, positive and axis. So like this, in the is for the AN toward the center, and for the AT, magnitude is derivative of the velocity. Analysis is similar to the rectilinear. So AT equal to dV dt. And there are two common methods for same as velocity before. So there are two common methods for the analysis. The first, trigonometric, and the second is rectilinear component, rectangular component. And for observation, there are maximum of 5 quantity involved in relative acceleration. That is for AN and AT, there are 4 unknown. And for this one is for A, particle A. And for particle B also we have normal acceleration, tangent, tangent acceleration for the magnitude and direction. And also we have magnitude and direction of acceleration B relative to A. And there must be only 2 unknowns in 2D. For the rectangular component method is usually preferred when analysis involves 8 or more quantities. Okay, for we have uh, 8 or more quantities, it's preferred rectangular. And for 6 quantities, it's preferred trigonometry.